Alright, this is our sheep heart. Looking at the anterior side, so the front side of the heart. Here's the apex right here. This is where the left ventricle is. And this side of the heart is a lot firmer if you're able to touch it, because the muscle wall is thicker here. It has more work to do. This is the right side of the heart. It's the right ventricle over here, and you can kind of see running across the front of the heart is the anterior interventricular sulcus. And this is where you have some significant veins and arteries going to feed the muscle wall of the heart. Surrounding the heart, which has all been cut off, is this sort of tough membrane called the pericardium. Fibrous pericardium is the part that I've left here. The part that is in contact with the heart is, let me back up a little bit. The deep portion of the fibrous pericardium is lined with the serous parietal pericardium, and then that doubles over and covers the heart directly, the visceral serous pericardium. Those two layers secrete serous fluid, and as the heart beats, that decreases the friction between the muscle of the heart and the pericardium and surrounding structures. Okay, so front of the heart, apex, base. This is the atrioventricular groove going across the top. First great vessel that you see is the pulmonary trunk, and that kind of runs at an angle. It's coming from the right ventricle over here, and it's going to go up to the lungs. It splits a little bit higher up. One portion going left to the left lung, one portion going right to the right lung. And those are the pulmonary arteries. They're carrying blood away from the heart, but this is the only case where an artery will be carrying deoxygenated blood, because it's coming from the right side of the heart, hasn't gone into the lungs yet. So the pulmonary arteries are the only arteries in the body that carry deoxygenated blood. Blood circulates around in the lungs, comes back to the left side of the heart, enters into the left side of the heart. This has been cut away by the people that took the heart from the sheep. This is where the pulmonary veins would enter the left atrium. And this is where veins are carrying oxygenated blood, and that's the only place in the body where a vein would carry oxygenated blood. Okay, so pulmonary trunk right there. Just behind it is the aorta coming out of the heart. If you stuck your probe down in there, it would go, and I'm sticking it in the brachiocephalic artery here, it would go all the way down into the left ventricle. Remember, this has received oxygenated blood from the heart, lungs now, goes down into the left ventricle. When the heart contracts, that squeezes blood up through the aorta here, and brachiocephalic artery, that's the first branch off the aorta. Aorta then circles back around behind the heart, becomes the descending aorta, and this heads up to the head and the right side of the body, or the right foreleg in the sheep. In us, it'd be your right arm. Between the aorta, right here, and the pulmonary trunk is this tough fibrous connection called the ligamentum arteriosum. There's your Harry Potter spell, ligamentum arteriosum. Right, Mr. Jones?
That is correct.
Okay. The ligamentum arteriosum is this connection here that used to be a bypass in the fetal heart between the two great vessels there, called the ductus arteriosus. So in the fetal heart, ductus arteriosus. In the fully developed heart, ligamentum arteriosum. Most of you won't have that because they'll cut right below that, but it's there in mine. Okay, right auricle, left auricle, those sit on top of the atria, add a little bit of volume to the atria. If you come around to the posterior side of the heart, looks a lot more complicated back here. That should help you determine that's the back side. This is the superior vena cava up here, or if you're talking about a four-legged animal, the anterior vena cava, because we'd be going to the head end. and then I cut that open, but you would find the inferior vena cava down here, or posterior vena cava in a four-legged animal, because that's going to the back of the body. Okay, let's just go through atrioventricle. This is the right atrium now. I've cut into the superior inferior vena cava, so we're looking into the right atrium. In the front there is the pectinate muscle. Can you see it there? There's little ridges of muscle in here. And in some of your hearts, you might be able to see the depression that was left behind. Let's see if I can. This is why surgeons have nurses. This would be the area where the fossa ovalis is. That is also where a bypass used to be in the heart, the foramen ovale, or oval opening between the two atria. This is now the interatrial septum. And this depression left behind is the fossa ovalis. Okay, so there's the right atrium. This is where superior vena cava, inferior vena cava, and then the coronary sinus, which is this opening down here by my left thumb. This is where blood that has been circulating around the heart itself comes back to the right atrium so that it can go up to the lungs eventually and get oxygenated. Okay, right ventricle came down through the pulmonary trunk. This pulmonary semilunar valve right here. This is where blood from the right ventricle is forced up and out through the pulmonary trunk. These valves only open this way. And then once the heart stops contracting, pressure of the blood in the pulmonary trunk falls back and kind of shuts that valve. There's a little valve there. Can you see that okay? Okay, now we're looking into the right ventricle. You can tell because there's the moderator band right there. That helps conduct the signal from one side of the heart to the other. Across the right ventricle there. And then chordae tenonnae are these little tiny white stringy things that are attached to the flaps of the tricuspid valve here. This is the tricuspid. There's one flap here, another one in the back there, and I may have damaged the third one. No, I don't think so. We just can't see it. Papillary muscle hangs onto the chordae tenonnae. As the heart contracts, papillary muscle pulls just a little bit on these chordae tenonnae and keeps the flaps of the tricuspid valve from going backwards up into the right atrium as blood is forced up. So these get pushed shut by pressure of the blood. Chordae tenonnae hold them in place so that they don't balloon back up into the right atrium. Got that? Papillary muscle, chordae tenonnae, one of the flaps of the tricuspid valve, and moderator band. Kind of hard to see the trabeculae carnae on this side, so I think I'll wait till we get to the left ventricle. Okay, so blood goes up through the pulmonary semilunar trunk, circulates around in the lungs, comes back into the left atrium, which is this guy here. Pectinate muscle up here. Auricle space up in here. Now we're looking down through the bicuspid valve or mitral valve. This is on the left side of the heart. Looking into the left ventricle. No moderator band here. So if you don't see a moderator band, we're on the left side. Plus, look at the thickness of the muscle wall here. The myocardium is really thick on this side. This side has to pump harder. It's got to get blood all the way out to the bottom of the body. Stretching across here are chordae tendineae, papillary muscle down here, more chordae tendineae in the back here, hanging onto the flaps of the bicuspid so that when the left ventricle contracts, these bicuspid valve flaps don't go up into the left atrium. And if you zoom in there, you can kind of see the ridges of muscle in the left ventricle there. That's trabeculae carneae. You'll see this on both sides. It's a little easier to see on this side. Okay. All right, heart contracts. Blood is going to come up through the aorta. And it's going to be real tough to see the aortic, well, maybe not. Can you see the little flaps there of the aortic semilunar valve down there? Those push upward into the aorta when the heart contracts. Right there. Good. Awesome. Mr. Jones lending a hand there. And when the blood pressure drops as the ventricle stops contracting, blood falls back onto that semilunar valve and shuts it. It's the closing of the valves that you hear when you hear the heart beat. That dum 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 dum. That's the valves closing. All right. So there you go.